Alright, in this video we'll be going over the csharp dotnet video tutorials. So we'll be continuing with polymorphism. So polymorphism allows derived classes to have methods with the same names as methods in their base classes. So it's kind of like a shadow, or it's kind of like shadowing a method, except basically it gives the ability for a program to call the correct method depending on the type of object that is used to call it. So it's a little confusing. Excuse me. So we have so we'll just talk about the definition again. So the term polymorphism refers to an object's ability to take different forms. So it's kind of like if you've heard the term morph, like something can morph into something else. You may have seen it in like a scientific fiction show or something. But it's a powerful feature of object-oriented programming. So in this section we look at two essential ingredients of polymorphic behavior. May have talked a little bit about this maybe earlier on in the notes. Sorry, I'm losing my page here. Okay, so I may have talked about this earlier on, so we're just going to continue it here. Some of the definitions that I'm going to say I may have already said, but this is going to be a better understanding of it. So number one of the two essential ingredients of polymorphic behavior is the ability to define a method in a base class and then define a method with the same name in a derived class. So we can maybe just write this down. Actually, I think we already did, so I'll just skip that. So the ability, so when a derived class method has the same name as a base class method, it is often said that the derived class method overrides the base class method. So you may have heard that before. Maybe not actually, perhaps in my Java series. Definitely in my Java series. I may have said that here or there. We're just going to talk about it now. But that's what overriding a method means. So pretty much, so when a derived class method has the same name as a base class method, it is often said that the derived class method overrides the base class method. So basically on the object, depending on the object, you could have a different method call. So the ability to call the correct version of an overridden method depends on the type of object that is used to call it. If a derived class object is used to call an overridden method, then the derived class's version of the method is the one that executes. If a base class object is used to call an overridden method, then the base class's version of the method is the one that executes. So we'll have an example here. So you can create a couple classes here. So I have the animal class. So I've created an extra class named animal. So we have animal, and then you can create that, and then we have dog, and then cat. So I believe dog should have been inherits from animal. And then cat also inherits from animal. Okay, so let's do an example. So let's set some of this stuff up. So we'll have a backing field in the animal class called species. So private string underscore species. Then here we'll have the constructor public animal takes a string species as a parameter. We'll open a block, we'll say that underscore species points to the parameter species. Here we can have the property Okay, so we'll have excuse me. So I have a public string here. So we'll just reference the property name, and then we'll just remember the property name is going to have no parentheses and the type that the property is, and then here we'll just say get. We'll open a block, return the backing field underscore species, and underneath we'll have set. Open a block, then we'll say underscore species points to value. Okay, so here we'll have another method named make sound. So we'll say public virtual void. I forgot what virtual is. I have the docs here. What does virtual mean? Just trying to remember what it means. Okay, so the virtual keyword, okay, oh yeah, so I remember now. So the virtual keyword declares that a derived class is allowed to override this method. Okay, so there's a keyword like this in Java. Excuse me, is it the overrides keyword? Can't remember right now, my memory's kind of bad. Okay, so we have pretty much, okay, so we'll just talk about this here. So first, hold on, so let's go back to this method. So we'll talk about what the virtual keyword actually means in a sec. So public virtual void make sound. It's kind of an interesting keyword. Virtual, I mean, has nothing to do with overriding at all. It doesn't have any connection, it seems. Overrides might have been a better keyword. That's alright, it's just Microsoft for you. So we have public virtual void make sound. Actually, this M should be lowercase. So here, it's not going to take a parameter. So we could say that we have a message box here, message box.show. What's up with this? I'm gonna have to import something here. What's the shortcut to do that? Alt plus enter. Okay, so if you're on Rider, it's Alt plus enter. I have the same key map as Visual Studio, so it might work. So I just hovered over it, hit Alt plus enter, and then it included this using systems.windowsforms directive. So messagebox.show, and then here we'll pass in gr, or like growl or something. So the virtual keyword, the virtual keyword that appears in the method header declares that a derived class is allowed to override this method. So let's just write a note here. I can't remember in Java if you need to write overrides or if you can just override them. I feel like there is a keyword. Overrides. I can't remember now. It's been a while since I've actually done OOP in Java. I like OOP though. I think it wouldn't be bad to get into the space later on. So here we have, so we'll be talking more about OOP stuff. We have C++ to do. So if you're interested in that, just stay tuned. After JavaScript, we'll be doing that. So here we have public virtual void make sound. So virtual declares that a derived class can override this method. So messagebox.show and then growl. So the virtual keyword declares that a derived class is allowed to override this method. So this method can be overridden in a child class. So in a derived or a child class or a subclass, which means all the same thing, the make sound method can be overridden to make its own sound, basically. Okay, so here's an example. So we'll do an example here that uses an instance of the animal class. That's only the animal class. We still have cat and dog to do. But let's just try to instantiate an object here, maybe in main. So there are some more classes. What's up with this? Does not contain a parameterless constructor. Okay, so there's gonna be, you're gonna get an error here. So I usually just do it as the last constructor, not the first one. So I go with public. We'll just go with public animal here, parameterless. We can just say species points to null, like that. Or actually, no, we could just say that it's an empty string. It's up to you. Null or just an empty string is fine. Whoops, what happened here? Underscore species points to an empty string. Oh, forgot the last brace here. Okay, so now that should be fine. Dog and then cat. So now we can go to the form here and then we can just erase these two. We can say animal. Animal points a new animal. Remember, the last animal is going to have parentheses for the parameters if there is any, which there's not in this case. Actually, I think there is. Let's go check this here. Okay, so it takes a species. Let's just say it's a oh no, let's just say that it's a jungle cat. Next we have growl. So here we'll say message box dot show. We'll say the species is plus animal dot species. We can say animal dot make sound. Excuse me. What happened to make sound here? Why isn't it letting me call make sound? Oh, sorry, I forgot the method call headers. Or the parentheses. Okay, so that's fine. So I'm just going to run it and describe to you guys what's going to happen here, because you won't see the pop-up, so I'll just run it here. So pop-up window is just going to come up and say that it's a jungle cat, and then it's going to say growl, and another, actually what happens in growl, another message box should pop up, so we should get 2 message boxes. Okay, something's wrong here. Oh no, it's trying to run classes that I already did in the last video. Excuse me. So let me try to delete those. Rectangle, I'm going to delete that. That's from the last video. If you saw that, can we just delete that? I don't think it's letting me here. Oh great, okay, that's not good. That's not good at all. Okay, so let's go to that class, delete everything. same for box here. Try to run it. I'm not sure if it's going to work. That's the problem with forms. When you have extra class, when you start in something new, you should just create a new solution. Okay, so it worked this time. So it says the species is jungle cat. Growl. So 2 message boxes appeared, then the form popped up. So that's about it. So no actual polymorphism yet. Okay, so let's do the dog class. One sec here. So we have class dog inherits from. Whoops. Let me just close the rectangle and box classes. Okay, now we have dog, so we'll say we have a string name here. The syntax is a little confusing in C# when we're referencing the parents' parameters for the constructor. So we'll just try to, we have to use the base keyword. So it's not that hard to do, but we'll just do it here. It's different than Java for sure, little different. So here we'll have a private string, and of course the virtual keyword is something new as well in C#. I guess they can't make the language exactly the same because it's kind of like a copyright. I guess they tried to do their best with that. Maybe they talked to whoever owned Java at the time when they were creating it, and they said, yeah, we want to make this language like Java. We really like Java. Java's a really cool object-oriented language. We want to make our own object-oriented language and have a lot of similar traits so coders or programmers can switch between the two frequently. So it seems like they did that, and then C++ gave them a call as well at some point later on, or was it before? And then the 3 just kind of had some kind of relationship later on. Okay, so pretty much, so we have private string underscore name, that's our backing field. But again, they could have just like capitalized it, because they did that with a lot of other things in the language. But maybe they don't want to, maybe like for some kind of copyright, they don't want to make it exactly the same. I don't know, whatever happened with that. Or they just wanted to make it stand out or just piss everyone off. Okay, so we have a private string underscore name. Then we have another, so sorry, not another, we have our constructor here, so public dog. So we're going to reference the class name. We'll pass in a string name. So you can do this on the same line. That's what I thought you could. You could do it on the same line. For the rest, for the species. So what else do we have? We have a species here. So in Java, I believe you use a super keyword to do it. So in this case, we have our underscore species backing field. In this case here, we could just go colon base parameter. Then we want to pass in, what do we want to pass in for the species? We want to say dog. Whoops. In here, in the actual parentheses. So remember, this is actually using the parents constructor to set up the species. Okay, so sorry, where am I here? Okay, so we're at animal. So here, remember, this takes a backing field takes a species string, and here we have, this is how you set up a parameter using the parents constructor in the derived class or the child class. But remember, I believe the child class is what we said is that it doesn't directly inherit the constructor. It's a little bit confusing. Okay, so we have underscore name points to name, so we'll just set up the backing field to the child parameter here. Perhaps you could have referenced this, had another species or something, and referenced the parents. This parameter there, it might have worked. I'm not sure if you'd want to do that, but you could try it. I'm not sure if it's going to work. You can always try though. Excuse me, so here we'll have another property. Well, we'll just set up the property, so we'll say public, the type string, then we'll capitalize whatever the backing field is without the underscore. We'll open a block, we'll say underscore, we'll say get, we'll say return underscore name. Here we'll say set, and we'll say, what are we going to say? We're going to say underscore name points to value. Oh, there is a override method. I mean keyword. Okay, that's what I thought. I thought I saw it before, and I was like, why do they have virtual? And I thought I was getting mixed up with Java. I haven't done this in a while, so it's pretty easy to use. So all you have to go here is just go underneath here and say public override, which is a keyword, void make sound, like that. Then here we'll say message box.show. I'll have to do that thing. Alt plus enter. I'm going to hover over message box. Hit Alt. What did I do? Something else. Hit Alt plus enter. It'll include that using directive. So message box.show, and we'll say I don't know. Bark. Okay, so we have pretty much that's about it. So what did we do here? We took the superclass. This is make sound method. We put virtual, meaning that it can be overridden. Then we went in the class itself, the child class, and said that we want to then override that make sound and have its own make sound. Have its own make sound method. So the constructor in the dog class takes the constructor in the dog class calls the base class constructor, passing the string dog as an argument. The animal class constructor assigns the string dog to the species field, or the underscore species field. Excuse me. So although the dog class is derived from the animal class, the animal class's make sound method is inadequate for the dog class. So let's just see what we have here. Public. Okay, so it is public. It's not private. It's not protected. So technically any class can access those. So it would have been better to use protected here. But the docs I looked at didn't have anything about protected so far. So you can just use protected. I've talked about it a bit at some point. I did a video on it. just one video, but you can make it protected that way. And basically subclasses of animal can access those fields and methods, or event handlers, well, I guess not constructor, but I guess yeah, constructor. But pretty much even the class itself, you could try and see if it works, having it protected here. Excuse me. Sorry, I have my throat's kind of bothering me. Okay, so we have, if you have private here, anything can't access this class. But if you have public modifiers here, access modifiers, pretty much any class can access this stuff. So I'd go with protected. There, basically if you have protected, then only child classes can access that stuff in the superclass. So although the dog class is derived from the animal class, the animal class's make sound method is inadequate for the dog class, so the dog class overrides the animal class's make sound method. The dog class's make sound method, so the dog class's make sound method displays bark in a message box, which is better for a dog. The override keyword also appears in the method header. The override keyword declares that this method overrides a method in the base class. So I believe Java actually has an override. I think it does. It has a override. I can't remember completely, but I have examples of that on my channel. That was like the second language I learned, so that was a while ago. I think I'm on like my 5th now or something. Okay, so we have, let's see. That's pretty much it. So now let's instantiate a dog object. So go with this constructor here, or yeah, so the form1 constructor. So we can actually just delete this stuff here, or we can just comment it out first for now. Lots of stuff going on in this lesson here. The polymorphism has a lot of parts to it. Inheritance, you have to use different keywords. There's the actual polymorphism we haven't even spoken about yet, so it's tricky. So hold on here. So we'll instantiate a dog object here. So we'll say dog points a new dog. The dog, I think it takes a species, so we can just say that it's a, I don't know, what's a dog? We'll just say coyote or something. Is that a dog? No. It's a wild dog. Is it technically a wild dog? I don't know. Let's just go with that. So we'll say pretty much here message box.show. And here we'll say the species is, with a space, concatenated to dog.species. Why is it calling days a week? Okay, so dog.species. Sorry, I couldn't see what was typed there because the IntelliSense just goes over the word. So message box.show, the species is concatenated to dog.species. Then here we'll say that message box.show the animal's name is plus dog.name we'll say dog.make sound. Okay, so that should be all. So let's just run this here. So I'll describe what's going to happen. There's another one here too. Okay, so it says the species is dog. Excuse me. So the species is dog. The animal's name is coyote. Bark. So in our dog class we have name. Okay, so just the name of the dog. Okay, so let's just talk about the description here. So we instantiate an object of the dog class passing in the string. What do we pass in? Coyote. The object is referenced by the dog variable. Then we display the species is dog in a message box, and then the animal's name is coyote in another message box. Then we call the dog object's make sound method. When we use a dog object to call the make sound method, the version of the method that is, so I think this is a polymorphism part right here. So when we use a dog object to call the make sound method, the version of the method that is in the dog class is the one that executes. So if the statement, okay, so that's pretty much it. Let's try one thing here. Let's go to the animal class, take out virtual, and then go to the dog class, take out override. Is there an error? Just a warning. Nothing. Just a warning, okay. Is it gonna run? What's gonna happen here? So let's try that, see what's gonna happen. What do you think's gonna happen? Okay, do we have the exact same method here? We called it on so the dog make sound is still gonna execute, I think. Yeah. Bark. Yeah, that's correct. Make sound. Why is that? The reason is because we didn't say animal dot. Whoops, sorry. In here. In the form. Dog dot. Could we have changed that? Dog dot animal. No. Could we have done animal here? Actually, no, it's not static. Okay, so it would have to have been static to do that. Okay, never mind. So yeah, it still works. But pretty much you'd want to stick with the virtual keyword in that case. Overall, it didn't really have an effect though. But we were able to override it. We're not able to access that one in particular though. Dog.make sound. Make sound. In class dog. Okay, because we're creating a dog object. So that's it. So let's just go back here. We'll add the virtual keyword. And then we'll go to the dog class, and then we will add public override. Can we go public void override? Nope. Okay, so it has to go before the void. So I'm just going to save it and run it. There's actually one more to do after. We probably will come back. Just a little bit more to do. There's more to talk about, and there's more polymorphism examples here, so we'll do that in the next one. So it says the species is dog. The animal's name is coyote. Bark. Animal we had growl, so the dog makes sound it execute. So that's going to be it for now. So thanks for watching, guys. If you guys liked the video, you can like and subscribe to support the channel for more programming and investing tutorials. So pretty much in the next video, we'll be continuing with polymorphism. If you want to see the rest of the videos, it'll be in the csharp.net playlist on my channel. So thanks for watching, guys. Hopefully I'll see you guys in the next one. Take care. Thanks.